urea. So, uh, so there are the as per the syllabus, you have to determine the not only the hardness of water by the EDTA titration, but also determine concentration of some metal ions with which EDTA forms very stable and stable and strong complexes uh, like copper and nickel. So today we will to discuss the determination of copper in any solid or liquid sample which has unknown concentration by EDTA titration. So the procedure more or less remains same, the reaction remains same. The only difference is that there will be some indicator is changed. Uh, let's go to the presentation. So determination of it's not copper nickel, it is copper. Copper by direct titration with EDTA. So quantitative analysis of copper can be done in any solid. As I said, if you are given a solid sample, you can dissolve it in aqua regia or mostly in the nitric acid and then concentrate HCl and then find out and then make up volume to so say 200 is 200 milliliter or 250 milliliter and then find out the concentration of copper in that liquid and then ultimately correlate that concentration with the amount of the solid that sample that you have dissolved. So the quantitative analysis of copper is in a soluble copper salt can be the technique can be used for any solid sample also, provided the sample is first digested and made soluble in water. Will be performed by complexometric titration. The complexing agent will be ethylene diamine in the form of disodium salt. As you know, this compound is available in the market in the form of disodium salt with molecular weight of 372.24 grams per mole. EDTA forms complexes with many metal ions. So this particular method can be used in the absence of ions like calcium, nickel, etc. The reaction of complexation is like this: that you have copper aqueous EDTA forming this 1:1 hexadentate EDTA complex is copper to form a 6 coordinate complex. This is the shape of the complex. The indicator used in this titration is mercury oxide. This indicator is highly colored and will form complex with copper ion to give a different colored species. During the titration, EDTA forms much more stable complex, as was the story with calcium and magnesium, and freeze the indicator, and which then displays its original color. That's the end point. So appearance of free indicator means that all the metal ion have been complexed by the EDTA, which signals the endpoint. So the preparation of the solutions. So we will prepare zero point 0.05 molar EDTA, use EDTA as it is in the bottle or weigh required amount. So you must first, dry it at 80 degrees Celsius because there may be some moisture on an analytical balance. So dissolve it slowly. So its dissolution is a bit slow, and therefore one has to be patient. So solution should be standardized, and you know how it standardization is done. We did it last time. So calcium carbonate is used for standardization. Standard solution of calcium carbonate is first prepared and EDTA is standardized by that. If the solution is not to be used in 48 within 48 hours, it should be stored in plastic bottle. It cannot be stored in glass bottles for longer period. So students should standardize EDA with known use procedure which was used earlier. So preparation of pH 10 ammonium chloride buffer. Dissolve 70 grams of solid ammonium chloride in 600 milliliter of concentrated reagent grade 15 molar ammonia and then dilute the mixture to 1 liter. That gives the 10 pH buffer solution. Throughout this experiment, it is essential that glassware and associated equipments must be clean and should be rinsed thoroughly with deionized water. Trace amount of certain cations found in tape water, such as copper, cobalt, these should be absent because otherwise there will be error. So this is indicator. The mercuric oxide, it is organic compound and it is ammonium salt of an acid, commonly known as purpuric acid. It is purple solid that is soluble in water. So color will be purplish blue, original color. The compound was once used as indicator, always used as indicator. Aqueous solutions are yellow at lower pH. At acidic solution is yellow, reddish purple in weakly acidic, and blue purple in the alkaline solution. So now, how is experiment done? They rinse your burette, fill it with standard EDTA solution. Weigh accurately the approximately 1 gram of the copper salt or sample. Dissolve the take 2 3 different samples. You can use the copper strip or steel. Copper is present in many alloys, in metals, in alloys also. You can use this method to determine the concentration of copper in steel or in any in any solid sample, provided you are able to digest it, dissolve it in concentrated nitric acid or aquaregia if need based. So or simple salt. Dissolve each sample in 50 milliliter deionized water. Add exactly same amount of indicator to each. Now जब आप पिपिट करेंगे 3 4 फ्लास्क में 50 मिलीलीटर या 25 मिलीलीटर सोल्यूशन, हर एक में इंडिकेटर ड्रॉप डालने हैं because the color change is so it is color to color. Otherwise intensity of the color will change with different solutions and therefore that will create error. So same number of drops of the indicator should be added in all the solutions. आपके पास जो solution है जिसका आपने एनालिसिस करना है, उसके 3 4 कोनिकल फ्लास्क लीजिए और उन 3 4 में पिपेट कर लीजिए 25 मिलीलीटर या 20 मिलीलीटर, जो भी पिपेट का कैपेसिटी है, हर एक में सेम नंबर ऑफ ड्रॉप्स ऑफ द इंडिकेटर ऐड करना है और बफर ऐड करना है. If indicator solution is not strong, कि वो कलर नहीं दे रहा है, तो add more, but always same number of drops in all the samples. The indicator concentration should be about 100 milligrams per 100 milliliter of water. This indicator is highly soluble in water, so about 100 milligrams 100 milliliter में डाल दें. To titrate each sample with standard EDTA, light yellow color solution turns first green near the endpoint and then suddenly purplish blue at the endpoint. So this endpoint is fairly hard to see because it is one color change to green to the purplish blue. So put a white sheet of paper under your beaker and watch the color carefully. The distinct purplish hue due to the free indicator is key to observing the endpoint. Look at the complete absence of the green color. So for each titration, calculate the number of equivalents. Now using the normality equation at 1v1 and 2v2, you can find out the normality of the copper solution and then multiply it by its equivalent weight, and you can find out how many grams of copper are there. So for each titration, calculate the mass, calculate the amount of the copper. So then if you have taken a solid sample, then you will write, सपोज सॉलिड सैंपल को आपने 200 मिलीलीटर वाटर में डिसॉल्व किया था, इनिशियली एसिड से डाइजेस्ट किया था और फिर एक फ्लास्क में डाला था जिसका वॉल्यूम 250 मिलीलीटर तक था उसकी कैपेसिटी, तो 250 मिलीलीटर उसका वॉल्यूम किया था आपने। सो यहाँ से जो ये अपना ये स्ट्रेंथ मिलेगा कैलकुलेशन से, मिलेगा so many grams per liter. Then you will write 1000 grams of this solution contains so many grams, say x grams. Then 1 milliliter will contain x by 1000, and 250 milliliter will contain x by 1000 multiplied by 250. So that will be 1 by 4, right? So then you will write, suppose आपने सैंपल लिया था 1 ग्राम स्टील का, 1 ग्राम of steel contains this much copper. So you know 100 grams will contain this much. So that way you will या आपने साल्ट लिया था कोई, तो आपने 0.5 ग्राम यूज किया, so then you will write 0.5 gram of this salt, given salt contains this much copper. 1 gram will contain this divided by 0.5, and 100 gram will contain this much. So percentage में आप ग्राम by weight percentage में आप रिकॉर्ड कर सकते हैं अपना ये result. So this is what you will find out. Normality of EDTA will be known. The milliliters of EDTA will be given by burette. Equivalents of copper will be determined. That's normality of the copper solution will be determined from the normality equation. Normality of EDTA is known. Then you will find out from the normality of copper, you will find the grams of the copper, the mass of the copper, and percentage content. So that is how this experiment is completed. This is absolutely same experiment, which was, the procedure is more or less same as the earlier one. Only thing is that we are determining a different metal ion, that is copper second, can also be determined by complexometric titration, indicating that the formation constant or the equilibrium constant or the stability constant of the copper EDTA complex is very much high, so that it immediately forms complex with the copper, so that the complexometric titration can be used to determine the concentration of copper quantitatively in any solid or liquid sample, right? So this is another method, way to use complexometric titration to our advantage to find out the concentration of the copper. So that's all for today.